I'm Mary. I'm a second year resident in internal medicine and pediatrics at Mount Sinai here in Manhattan. I do my primary care clinic at Settlement Health on East 106th Street. I have an interest in doing community education around preventative healthcare stuff. Most of the information and photos from this talk are adapted from this article from the NIH from their site called Understanding COVID-19 mRNA Vaccines. Outline for my talk today: first of all, what the heck is mRNA? Second, how does an mRNA vaccine work? How do mRNA vaccines differ from traditional vaccines? So the rest of the vaccines that we got when we were kids, or like the flu vaccine. And then last, I'll touch on vaccine hesitancy and how that's been affecting vaccine development recently. Key points, I'll revisit them at the end too, but the high points from today: mRNA vaccines give your cells instructions to make a protein from the COVID-19 virus. Making this protein first generates an immune response without getting sick from the real virus. mRNA vaccines cannot alter your DNA, and they cannot give you COVID-19. mRNA vaccines have been in development for decades, way before the 2020 pandemic. And then lastly, vaccine myths and disinformation are affecting vaccine development. I'll talk about that too. Starting off with what is mRNA. mRNA stands for messenger RNA. I think we've all heard of DNA. So we hear people saying, oh, it's in your DNA, it's the code for life. DNA is basically just a cellular blueprint, or like a cookbook, like for everything that you would need in your body. The instructions are written down essentially in your DNA. It's permanent, it doesn't change. It can be modified, but the core cookbook, it's like the OG grandma's cookbook. Things don't change from that one. mRNA is a disposable copy of those instructions. So say you have grandma's cookbook that has all the recipes, but you want to just make one recipe. So you write it down on a note card and put it up on the counter when you're making your food, so the regular cookbook doesn't get dirty, because you don't need the whole thing. You just need a little bit. And after, you can throw the note card away. That's what mRNA helps us do. The sequence will go from DNA, and then we'll make a little copy. That's mRNA. It's a small little molecule, disposable. It's only a section of the DNA. It's not the whole thing. And then from the mRNA is how our cells make proteins. And we hear about protein a lot. We use it to mean a lot of different things. But today, what I mean when I say protein is the final end product of this DNA, mRNA to protein process. The proteins are what do everything in our body. The proteins are that final product. They're the meal we were trying to make the whole time. An example from your body is the digestive enzymes in your stomach that digest your food. Those are types of proteins that have a specific job. So we give proteins specific jobs in our bodies. The COVID-19 virus also makes proteins. You may have heard of the spike protein, and that's the protein that it makes on its surface to help it enter our human cells and infect them. So the COVID-19 virus has DNA that is then transcribed into RNA and then made into a protein, just like inside all of our cells. But the COVID-19 virus's job is to make this spike protein. So how does the mRNA vaccine work then? The COVID-19 virus has the code in its DNA to make the spike protein. So DNA is kind of like your computer, coded in like ones and twos. Your DNA and the virus DNA is coded in all these letters, A, U, G, C. So whatever combination, like a specific combination of those letters, is what's going to make a specific protein. So thankfully, we can find out in the lab. We can take a sample of a COVID-19 virus, look at its DNA, and find that exact code for an exact protein, being the spike protein. That allows us to kind of sneaky make our own copy of mRNA in the lab. So we can say, hey, we got this code for the spike protein. We can make our own copy of the mRNA without the virus doing it itself. So our mRNA vaccines then allow us to bypass the need for DNA, which essentially means we don't have to be infected with an actual virus in order to get an immune response. So we don't need the virus DNA because we can make our own sneaky little mRNA protein in the lab, which will then in our cells make the spike protein, which will then trigger an immune response. So with that spike protein code, show our own cells the manufactured mRNA, which will give our own cells the directions for making the COVID-19 protein. Our cells won't know the difference. Once that mRNA is made in the lab, it's put inside this lipid bilayer. So this like kind of fatty envelope, basically, fatty little sphere. That's what will protect it. mRNA degrades very quickly. And so this little sphere is what will protect it and allow it to get from the factory to our pharmacy or to our clinic and into our bodies. So an overview, starting with the SARS-CoV-2 virus, which is the virus that causes COVID-19, which is the disease. We're looking at just that spike protein on the outside. That spike protein, we can figure out the mRNA little code that makes that spike protein. We can put it in the lipid little bilayer, put it in a vaccine syringe, send it into our cells. So that's the part where it goes into our body. That little mRNA then can go into our cells and make the spike protein without having the whole virus. It can just make that little piece. Then that little piece is what will teach our immune system to defend against COVID. The spike protein is what will trigger that immune response, and you'll be protected against COVID-19 without ever having to see that whole ugly actual COVID-19 virus. How is this different from the traditional vaccines, the rest of the vaccines that we've gotten in our lives? So any vaccine, the way that it works is to teach your immune system to defend against an infection without having to get that infection. It's like a cheat code for being immune to an infection, because you could be immune to COVID by just having COVID and having the infection, but we don't want to get sick in order to be immune. Sometimes it's a mild case of COVID, as we know, but sometimes people get really sick and end up in the hospital. So all vaccines work to teach our immune system to recognize either a virus or a bacteria, in this case, a virus. The traditional vaccines usually are made by showing your body a weakened or inactive part of the virus or the bacteria. So it's taking the actual virus or bacteria, cutting off a part of it, or basically killing it, and then showing it to your body. The cool thing about the mRNA vaccines is there's no viral material. You don't actually get exposed to the virus itself because you're teaching your own body to make a little mimic of that part of the virus, of that spike protein. So that's why you can't get COVID-19 from an mRNA vaccine. You're not getting the virus into your body at all. A cool thing about the mRNA vaccine is it's not just the COVID-19 vaccine. Now that we know how this process works and we know that it works pretty well, it's easy to find out what the code for virus DNA is, and then from there make an mRNA vaccine. That process can take days to weeks, which is much faster than the traditional vaccine development, which can take years. So decades of research that was going on to develop mRNA vaccines before the COVID-19 pandemic even happened. We were really lucky that we were sitting on all of that research and it was ready to go and given a big boost of funding to get going into production right when the COVID-19 pandemic started. Vaccine hesitancy affecting vaccine development now. I understand that the mRNA vaccines being different and everything around the pandemic seemed really rushed and new. And there's a lot of worry now in the general public about what vaccines do for us or what they may or may not do. As we've seen in the news with the measles outbreak in Texas, it's now really coming to fruition and really making a difference in people's lives. And this is a relatively recent article from April 8th of this year on CNN with the worry that anti-vaccine sentiment is actually causing issues, derailing vaccines that are awaiting FDA approval. So there's vaccines that are awaiting for the FDA to say that they're safe and effective, but anti-vaccine sentiment has now gotten to higher levels of government, and some state legislatures are trying to ban mRNA vaccines. There's a big lobby against these vaccines that will lead to decreased immunizations. And I think this quote is perfect. Low vaccination rates create a perfect environment for the spread of infectious disease. And that's exactly what we are seeing in Texas with the measles outbreak in children and adults. And unfortunately, that's what we saw at the beginning of COVID when no one was vaccinated in March, April 2020. There was a lot of spread of the infectious disease. So a good reminder of how information spreads, both good and bad. So we have sensational TikTok videos down in the right-hand corner. But I like to think about just having one-on-one conversations with people that we know as the most effective way to combat disinformation, answer questions in good faith. So I hope after today, you can have a conversation with at least one other person in your life about what you learned today, feel empowered to ask them if they have questions about the mRNA vaccine, either answering them yourself or directing them to someone who can answer the questions. So coming back to our key points, mRNA vaccines, they give your cells instructions to make a protein from the COVID-19 virus. Making that protein will generate an immune response in your body. So it'll teach your body how to defend against the virus without having to actually get sick from the real virus. mRNA vaccines cannot alter your DNA or give you COVID-19. We're copying that mRNA. It doesn't get integrated into your DNA in any way. I think the confusion comes from mRNA sounding similar to DNA or something like that. mRNA vaccines have been in development for decades. It's not something new that we're just trying out. And then vaccine myths and disinformation are actually affecting vaccine development and people's lives, unfortunately, right now.
One of those things where sharing accurate vaccine information helps forward the research. For incurable viruses, maybe like HIV, I'm just throwing that out there. Is there the potential for something like mRNA research to apply to that as well, just because it's also a virus?
Different viruses infect our cells in different ways. Fortunately for us, the COVID-19 and flu virus and a lot of the common cold viruses do not burrow into our DNA. Once we are cleared of that infection and our body knows how to defend against it, it's not integrated into our cells. There are some viruses like HIV and then some of the hepatitis viruses are two examples. Those viruses are evil and sneaky in that they burrow into our DNA and they actually hijack your DNA into replicating the virus, permanently integrated into your cell in that way. So from my knowledge, at least, that's the reason that an mRNA vaccine wouldn't be applicable to HIV. I'm super willing to be wrong, and I'm super excited if someone could figure that out in the future. But for right now, that's a barrier to having a vaccine against something like HIV, unfortunately.
The more we spread accurate vaccine information, the more support there is for research